All right, this is part 1-2, chapter 11, looking at vaccines and immunological memory. And I wanted to start off with 1 Chronicles 16:34, which says, "Give thanks to the Lord, for he is good, his love endures forever." And I hope you all can feel that we are always surrounded by God's love. That all we need to do is to take time to stop, to look to Christ, and we have his love. And I like how it says his love is forever, it endures forever, because that can relate over to our immune system, where we can develop immunological memory, which in some cases can actually be forever or lifelong. Alright, so in this chapter, we will look at some differences between the primary versus the secondary immune response, even though most of what we've been looking at so far this semester really involves the primary immune response. And the purposes of the primary immune response is to clear infection, to temporarily strengthen defenses to prevent reinfection right at that time of the first infection, and then to establish a state of long-term immunological memory in case we see the same microbe again. Alright, the secondary immune response, though, is subsequent infections. Alright, and generally, obviously, we have this memory because of either a prior infection or a prior exposure. Alright, but that secondary immune response is much faster. It's going to involve low levels of circulating antibody, and these actually are very low, almost to the point of 0. And then utilizing the long-lived memory B and T cells that were created in the primary immune response. And this is where the response time differs, is because now we don't have to go through that naive cell stage of needing the B cell to interact with the T helper cell, and then the T helper cell having to interact with the B cell, and then the T helper cell having to interact with the cytotoxic T cell. Those memory cells are already created, and they can be instantly activated to go through proliferation and differentiation. All right, and so then many times, most times, you actually clear an infection before you even have symptoms. All right, both systemic and mucosal primary immune responses give or yield immunological memory, and vaccination safely creates a primary immune response to give that immunological memory. So up here, all right, the prior infection or exposure. The vaccine isn't always an infection, even though you can have an attenuated virus, all right, but it's going to be an exposure, and that exposure creates that primary immune response. All right, so big picture, what are the overall properties of immunological memory and the secondary immune response? How are memory B and T cells different in properties? And how are naive T cells suppressed and B cells suppressed in the secondary immune response? Alright, so here the section title is "The Antibodies Formed During Primary Immune Response Prevent Reinfection for Several Months After Disease." And what you'll notice for this chapter in Canvas is that I have posted a list of the chapter section titles. And even though we won't hit on all of the sections in the lecture notes or look at all the figures, the titles are actually good one-liners to understand immunological memory. So use that as part of your study guide or your organized notebook for immunology. So here, the primary adaptive immune response. These are new infections, new exposures. Even if you've just had a cold, a new strain of the same virus can induce a primary immune response. Since it's a new strain, your immune system may not recognize anything from it. All right, so here you have your infection, and you've got a lag time here. All right, this is probably time 0, and so you have 7 days before there are any measurable amounts of effector T cells or of antibodies. But over the span between, say, day 6, day 7, and day 10, you've got this rapid increase in measurable amount of effector cells and antibody. And that's right along par with what we know about the immune system. All right, then at this point, though, if you're talking about a cold, all right, sometimes colds hang on, but usually by day 7, you're probably already feeling better. And that's because your innate immune response is working, all right? But, with the fever, with the macrophages, the phagocytes, those type of innate immune responses. But also here, the effector T cells, as soon as those get produced, they can start helping fight that infection right there. And so generally, here's when you start to see the cold symptoms go away. All right, so then over time, even though you're not going to be sick anymore here from just a normal cold, your antibody levels are still going to be high. Effector T cells do start to wane. But at this point, if you get exposure to the same pathogen, the result is aborted infections. You're not going to get sick because you have those immune functions that are right there ready to go, and you don't even know that you are sick. So this primary immune response prevents reinfection. Right? It clears the pathogens before the adaptive response is mounted. All right? So you don't have a second increase right here in your effector T cells or antibodies because they actually still are working. Okay, so where were we? All right, here during this time frame, all right, you are protected if you encounter the same virus again or whatever microbe. And now we're out to years. All right, this is where you have immunological memory. However, plasma B cells do die off, all right, and the antibody levels do decline. And so you have what would be considered basal levels, or basically close to 0 levels of antibody. A little bit, but not a whole lot. Still slightly measurable, but not a whole lot. But what you do have are lifelong memory B and T cells that recirculate randomly. They can rejuvenate. They can go hang out in the bone marrow and just rest for a while and then just randomly get kicked out into circulation. And so then what happens? Well, then you have this secondary adaptive immune response. Why? Because you have a second infection or a second encounter. All right, and so this actually is only going to occur, the secondary immune response is only going to occur if the pathogen overcomes the innate as well as the residual primary immune response. So here you have some antibody left, not a lot, but possibly if you get a low amount of inoculating numbers of that second infection, that second encounter, right, the antibodies that are present are actually able to neutralize it and you don't get sick. And so you actually don't, if that were to happen, you wouldn't have this secondary adaptive immune response. But if the microbe were to overcome what's left here, then you would have a secondary immune response. And notice the time frame. And right back here, you're at day 0, and you don't see this measurable jump here until like day 6 or 7. Here, you're at like day whatever, 30 months, 2.5 years. All right, but you've got maybe a day or two in this time frame where you go from hardly anything to a lot more than you had in that primary immune response. So the secondary immune response is much quicker, and it's more efficient, and it's stronger. And your protective immunity lasts longer. All right, so that's why it's important when you think about getting booster shots for vaccines. Right? Sometimes, well, with kids, you've got, say, a shot at month 1, and then at 6 months, and then at a year. All right, this is what's going on that first time, then that second time, and the third time. You are increasing the amount of antibody. you're increasing and strengthening those secondary and tertiary responses to be better adapt if you were to come into contact with the organism. All right, so how does this memory develop? All right, well, this figure is not in your textbook anymore by itself. It has some crossover to a couple of other figures, but I've left it in here because I like it. But the section title is Immunological Memory is Sustained by Clones of Long-Lived Memory T and B Cells. All right, so here you have naive T cells and B cells are activated. This is in the primary immune response, and most activated T cells become short-lived effector cells. So these are going to be the effectors, those that do the work in the moment, but some become those memory cells, the memory T cells and memory B cells. And these are the cells, this part here is what builds the foundation for those secondary responses. All right, so then here you have, also still on that same idea, you've got the secondary immune response by these T cells, and B cells, these memory cells, that once they are activated, very quickly they transition over here to those effector cells to be able to move from a B cell to create a plasma cell that then secretes immediately high amounts of antibody, and the T cell that creates the effector T cells. All right, already isotyped, class switched, affinity matured. This process, though, gets even better with the tertiary and subsequent exposures. All right, so here, now for the real figure for section 11.3. All right, the naive T cell is activated by the pathogen. You've got these clones of effector cells, and in the primary immune response, you have more effector cells than you do with memory cells. And the effector cells are outnumbered, the effector cells here are outnumbered by the memory cells. All right, but here with the B cells, all right, you have the effector cells that are going to activate and cause differentiation of the B cells. All right, and in this case, effector B cells outnumber memory cells. All right, same situation. It doesn't matter if you are a T cell or a B cell. In that primary immune response, effector cells are always going to outnumber memory cells because at the moment your immune system wants to be able to clear that infection. All right, then we're talking about vaccinations. All right, the goal of vaccination is to immunize people with a benign form of a pathogen to induce immunological memory, to induce a response, so that then if you have any infection with the real pathogen, the pathogen meets that secondary immune response and terminates the infection before it actually causes disease. And a lot of times these scenarios are going to focus on viruses. So here a person gets vaccinated, all right, time 0, and it's for a virus, and the person is looking, or the test is looking at antibody, all right, in this person. All right, here's the unvaccinated, right, 0.04 in terms of units, almost 0, almost to the point of being unmeasurable in the unvaccinated person. And this is log scale, so here you have now 0.4 for the vaccinated person. This amount is actually so much higher, right, tenfold higher, a lot higher in terms of what this small amount of antibody can actually do for protecting a person. All right, and this is years, all right, years since last vaccination, even 80 years almost. There's still some measurable amount of antibody. All right, and then here, percentage of individuals with vaccinia-specific T cell memory. So vaccinia is the smallpox. All right, and here the different colors represent, in the blue, individuals who received only one vaccine.